Good morning everybody. In this video I present our recent contribution of wireless sensor network entitled an energy efficient protocol with static clustering zones, noted EEPSCZ. I have divided my presentation into 4 parts. In the first part I give an introduction of our work. In the next part I explain our contribution. In the third part, I talk about performance evaluation. In the last part, I give a conclusion and future works. Our work focuses on wireless sensor network, which is a set of sensor nodes that communicate through wireless links. Those sensors are equipped with batteries with a limited lifetime. So wireless sensor network should be designed to work for the longest time possible without replacing or charging batteries. For this, many routine protocols have been proposed to answer the challenges in designing an energy-efficient network. Among the proposed protocols, hierarchical routine protocols, also known as a cluster-based routine. To reduce energy dissipation, this strategy organizes the nodes into clusters. In each cluster, nodes send data to cluster head. This last aggregates the data and sends the results to base station. However, this can cause the energy depletion of the cluster head and involving a no send of data from this cluster. Among these cluster-based routing protocols, we see the latch protocol, in which the cluster head choice is rotated dynamically and uses the single hop routing, where each cluster head sends its data directly to the base station. However, in this protocol, the dynamic clustering induces extra overhead. This will be improved by the ICAASE protocol. However, the selected node later with this protocol can become bottleneck. To improve latch protocol, the EEPSCZ protocol has been proposed, which eliminates the overhead of dynamic clustering by partitioning the network into vertical layers. Each layer matches one static cluster, and the corresponding cluster head sends their data directly to the base station with a single hop, as shown in the figure. However, under this protocol, the cluster heads are chosen on the basis of the maximum residual energy, not always sufficient, and the use of single hop can rapidly exhaust the battery of cluster head and cause a problem in large networks. In our contribution, we propose an energy-efficient protocol with static clustering zones, noted EEPSCZ, to improve the EEPSCZ protocol by adding horizontal partitioning, which are in the form of a layer with clusters, using intra-cluster single hop and inter-cluster multi-hop routine communication. The cluster heads are chosen on basis of the residual energy, and the distance from the base station provides a cluster maintenance phases to keep the network alive for as long as possible. The proposed approach is divided into 4 phases. The first one is the initialization phase. It is executed only once during the entire routing process in order to perform clustering of the sensor nodes. The initialization phase is realized in 2 stages. The first is characterized by the layers formation, in which the base station supplies the network in L layers as shown. In the second stage, the base station supplies each layer on K-zones cluster and select randomly one temporarily clustered for each cluster as shown also by the figure. In the cluster head election phases, the temporarily cluster head designates as a cluster head the nodes having the maximum score where is given by the formula. In the third phase, called data routine phases, in the first stage, the nodes send their captured data to their cluster head, where in the second stage we adopt the multi-hops as routing machines in which each cluster head passes its data to the cluster head of its next lower layer closest to the base station. The last phases of our approach concerns the cluster maintenance, in which the cluster head takes the role of temporarily cluster head if its residual energy reaches 20% or 5% for data aggregation. In addition, if nodes have all assumed the cluster head rules, each node sends its data to the nearest neighbor cluster head of another cluster in same layer or other layers. And if all the nodes of the first layer closest to the base station took the role of cluster head, each node of this layer and cluster head of second layer sends its data directly to the base station. We evaluate the performance of proposed EEPSCZ protocol by comparing it to the EEPSC protocol in terms of residual energy after temporarily cluster head and cluster head selection, residual energy consumption, number of filed nodes after sending packets. The table summarizes the used parameters. The figure shows the residual energy of each node after selecting the cluster head by the EEPSCZ and EEPSC. We can see that the residual energy of the temporary cluster head is over than 0.68 joule with EEPSCZ and less than 0.65 joule with EEPSC. This due to the fact that each temporary cluster head dissipates a considerable amount of energy since it manages all nodes of its level. This confirms that efficiency of horizontal area partitioning and cluster head selection technique used in the EEPSCZ. Figure shows the residual energy of each sensor after sending 400 packets with EEPSCZ and EEPSC. We can say that the residual energy of several nodes is nearly 0.4 joule, where they dissipated on average 0.3 joule under EEPSCZ. Comparatively with EEPSC protocol, we note that the residual energy of several nodes is nearly 0.2 joule, where they dissipate on average 0.5 joule. We can say that EEPSCZ allows more residual energy than that obtained with EEPSC. Figures show the average amount of energy consumed when sending packets with EEPSCZ and EEPSC protocols. We note that when increasing the packet sending, the energy consumption increases for both protocols. We note that EEPSCZ manages to send up to 684 packets against EEPSC equal to 544 packets. Figure shows the number of filed nodes with both EEPSCZ and EEPSC protocols. We note that when increasing the packet sending the number of filers increased for both protocols. Note also that the nodes filing in EEPSCZ higher than that of EEPSCZ. This is due to the efficiency of the cluster maintenance phases in EEPSCZ. As a conclusion, we can say that our contribution adopts an organization of the nodes in layer and zones or clusters, takes into account residual energy and distance from base station in election of cluster heads, adopts multi-hops routing between the relay nodes of the different layers, which allows to consume less energy to reach the base station, provides cluster maintenance phases to keep the network alive for as long as possible. As a future work, we plan to study and enhance the problem of routing and wasting energy in context of ambient energy harvesting systems. We plan also to study behaviors of our protocol in a mobile environment. Thanks for your attention.